Welcome to the Beginner's Guide to Creation Care in the Climate Crisis. This is a project of the volunteers on the Earth Care team of St. Benedict's Episcopal Church in Los Osos, California. The topic for this first session is, what is climate change and what are its consequences? In it, you'll be hearing from John Horsley. John is a longtime member of St. Benedict's. He earned his PhD in chemistry from Oxford University in England. His career spans decades as a chemist in industry and as a professor. John brings his love of God and understanding of science to our climate efforts. John, thank you for addressing this important topic.
So what is climate change and what are its consequences? Some of the energy from the sun is reflected back into space by the Earth. So-called greenhouse gases, such as carbon dioxide, trap some of this energy and reflect it back to the Earth. And this plays an important role in keeping the average temperature of the Earth at a level where humans can thrive. The problem now is that humans are pumping increasing amounts of heat-trapping greenhouse gases into the atmosphere at a rate of around 2.5 million pounds per second, which increases the global mean temperature. Climate is the average weather in an area over many years, which usually remains stable for a long time, perhaps thousands or even millions of years. Due to the enormous amount of greenhouse gases that have been added to the atmosphere since pre-industrial times, and the resulting rise in the global temperature, the Earth's climate is now changing much more rapidly, and we are already seeing the effects. So where are we now? What's our situation? The global mean temperature has increased by just over 1 degree Celsius. That's 1.8 degrees Fahrenheit since pre-industrial times. And we are beginning to see some serious consequences of this warming. For a start, we are seeing an increase in severe weather events. A warmer atmosphere can hold more water vapor, which should lead to more extreme rainfall events, perhaps causing severe flooding. This is indeed exactly what we are starting to see. The trend is particularly dangerous when the increased rainfall is associated with a hurricane. Hurricane Harvey in 2017 produced more than 50 inches of rain in the Houston area, leading to catastrophic flooding, as we see here. Hurricane Dorian in 2019 produced a deluge of over 40 inches of rainfall in the Bahamas, again leading to devastating flooding. 5 states set rainfall records related to tropical storms between 2017 and 2019. There is also a trend towards stronger, more intense hurricanes, that is of category 4 or 5, due to rising ocean temperatures. Heat waves now tend to last longer, and maximum temperatures are higher. These heat waves can be deadly, particularly in countries that already experience high summer temperatures, such as India and Pakistan and countries in the Middle East. The intense heat dries vegetation, which becomes kindling for wildfires. Research has shown that climate change has already at least doubled the risk of extreme wildfires in California, and was a major factor in causing the enormous wildfires in recent years. Siberia experienced an unprecedented temperature of 100 degrees Fahrenheit in June 2020, and the heat waves cause massive fires, even in the permafrost and tundra. Sea levels are rising, in part due to normal expansion of water with increasing temperature. The melting of the Greenland ice sheet is now also contributing to the rise. As a result, coastal communities such as the Miami region are seeing many days of flooding as ocean water enters their streets, even without an assist from the wind. The very existence of some small island nations in the Pacific is threatened by rising sea levels. Climate change is one factor causing the recent decline in biodiversity. The survival of a species will depend on how rapidly it is able to migrate away from unfavorable climate conditions. And many species will not move fast enough to prevent extinction. Insects are particularly vulnerable to loss of habitat. Bird populations in the United States and Canada have declined by a third since 1970, mainly due to loss of insects. There are many reasons for the decline in insect population, but climate change is now becoming a significant factor. Ocean warming is leading to increasing ocean heat waves, which produce mass die-offs of marine life and creatures such as seabirds that feed on them. Carbon dioxide dissolves in water, producing carbonic acid. So increasing the amount of carbon dioxide in the atmosphere increases the acidity of the oceans. This is producing a catastrophic mass die-off and bleaching of coral reefs worldwide, as we see here. One of the most striking consequences of climate change in recent years has been the loss of sea ice around the Arctic, which has lost 2/3 of its volume in the summer over the past 40 years. This image from NASA shows the sea ice extent in September 2016. The sea ice would usually extend almost as far as the coasts of Siberia and Alaska in this month. The loss of sea ice causes more heat to be absorbed by the ocean, which further increases sea ice melting, and also the melting of the Greenland ice sheet. How this affects the rest of the planet is not yet known, but it has been suggested that it weakens ocean currents and the jet stream, leading to an increase in extreme weather events. So what is the future? Where are we headed? The 2018 United Nations Climate Change Conference in Paris set a goal of keeping the global temperature rise below 2 degrees Celsius. The stretch goal of 1.5 degrees Celsius may already be unattainable. Even if this 2 degrees Celsius goal were met, climate change would have severe impacts in many areas of the world. All of the impacts of global warming that we are seeing already at 1 degree Celsius would become significantly more severe at 2 degrees Celsius warming. One consequence of 2 degrees Celsius warming will be a huge increase in the frequency of deadly heat waves. These could occur every summer in some areas, leading to the deaths of many tens of thousands of people. There will be a corresponding increase in the demand for air conditioning, which will require more power plants, producing more carbon dioxide emissions in a vicious cycle. At 2 degrees Celsius, melting of the Antarctic ice sheets will start to make a significant contribution to sea level rise, on top of the contributions from the Greenland ice sheet and the melting of mountain glaciers, resulting in an acceleration of sea level rise. High tide flooding could inundate many coastal communities every year, and some of these would probably be abandoned. Some small island states could become uninhabitable. Flooding inland would also increase due to the increase in frequency and intensity of extreme rainfall events. More intense monsoons, in particular the South Asian monsoon, will unleash devastating flooding. Some areas will suffer from drought rather than increased precipitation, especially countries in Africa. This will lead to a lowering of the yield of important food crops, such as corn, which must be added to the lowering caused directly by higher temperatures. The disappearance of mountain glaciers will severely affect those regions that depend on seasonal glacier meltwater, such as the nations of Central Asia. In the Arctic, summers are likely to be nearly ice-free, which would strongly affect atmospheric circulation throughout the Earth. The Arctic would shift to a weather system dominated by rain rather than snow, disrupting its ecological balance and producing mass die-offs of wildlife. Although the goal set by the Paris Conference was a temperature rise of 2 degrees Celsius, even if all the pledges made by the participants were fulfilled, the temperature rise would exceed 3 degrees Celsius. In The Uninhabitable Earth, David Wallace Wells states, warming of 3 degrees or 3.5 degrees would unleash suffering beyond anything that humans have experienced through many millennia of strain and strife and all-out war. Some areas of the Earth will be exposed to temperatures above the threshold at which it is no longer possible for humans to survive. Even more areas will experience temperatures at which it is not possible to work outside during the hot season. This will produce mass migration from the affected countries towards areas with a more moderate climate. Rapid melting of the Greenland and Antarctic ice sheets will produce a sea level rise that could attain as much as 3 feet by the end of the century, and a much further rise in the centuries to come. Flooding, both coastal and river flooding, will affect many millions of people worldwide. People from low-lying coastal areas and floodplains will have to move. Coastal cities like New York will need to spend vast amounts of money to protect against flooding during hurricanes or superstorms. One study has predicted that New York will have to deal with 3 storms with the intensity of Superstorm Sandy every year, even at 2.5 degrees Celsius warming. At the other extreme, large areas of the planet will not have enough rainfall and will suffer from mega droughts, in some areas becoming deserts. Crop yields will be dramatically reduced due to droughts and excessive heat, leading to famines and millions of climate refugees. An important unknown in making predictions of the amount of global warming to be expected is the extent to which the release of greenhouse gases from the Arctic tundra will contribute to climate change. The additional warming will cause the release of even more greenhouse gases from the tundra. So the concern is that there will be a runaway positive feedback effect, making global warming impossible to control, a frightening scenario. The thawing of the permafrost will, of course, lead to severe damage to any buildings and infrastructure built on it, with enormous economic costs. In view of the catastrophic effects of 3 degrees Celsius warming, it is possible that the world will turn to geoengineering as a temporary fix in order to buy time while more permanent solutions are introduced. The most probable approach will be to seed the atmosphere with sulfate aerosols, which would block the sunlight and lower temperatures. However, the cooling effect will not be uniform across the planet, which could lead to unexpected and perhaps devastating consequences. Other methods seek to lower temperature by withdrawing carbon dioxide from the atmosphere by, for example, seeding the ocean with iron, which would increase the amount of carbon capture in algae. But these methods are even less promising. Carbon dioxide removal by direct carbon capture from the atmosphere using absorbents, for example, could nevertheless make some contribution to lowering greenhouse gas levels. And the Paris conference stated that such technology will be necessary if the goals of the conference are to be met. In fact, as Gian Antal pointed out in Climate Church, Climate World, we already have all the solutions that we need to address climate change. The cost of renewable energy, such as solar and wind, is coming down rapidly, and it is technically possible for nearly all countries to transition to 100% renewable energy by 2050. What is missing is the political will to end the dependence on fossil fuels and make the necessary investments in renewable energy that will prevent a catastrophic 3 degrees Celsius temperature rise. Above and beyond any technical solutions, what is most necessary, of course, is a change in our lifestyle and our attitude towards creation.
Thank you very much, John. You know, it's striking to me as I listen to you, and I've read a lot about climate change, is just when it's put together in this very concise way, what a compelling picture it is, and what a compelling call to action it is for us as stewards of God's creation to take action and to address these issues, which I know subsequent sessions of this series will be addressing. So thanks for your efforts today and your insights and the heroic compilation of information here for us to share in a brief time with our audience. Thank you so much.
Thank you.